Welcome to the stream, everyone. Today is the day 2 of the Prusa i3 MK3S Plus build. And I want to welcome everyone who's already joining the stream. I see Piotr. He's assembling his own Prusa today. Tutum Carmen is here. Hello. Welcome. Happy to have you here. I'm also looking at how many people are coming in. So it's already 10 people coming into the stream. I want to welcome everyone. Hello, Leiden. Welcome back. It's good to have you all here because this is challenging. It's an interesting build. The Prusa i3 MK3 and Hellbees is also there. Welcome to the stream. So once again, let me know where you're coming from, the countries that you're living in, just to have everyone, giving everyone a little bit of a warm greeting to all of you. I'm here, I'm live, yeah. I'm live. It is as warm there, and is it as warm there in Germany as it is here in the UK? It's 27. I guess it is probably in the studio. It's a little bit warmer. It's probably about 30. This time I decided to just ventilate a few minutes here when I came, and then now I've closed the windows because of the noise outside. So Leiden is coming from France. Stavros is from Cyprus. Hello, welcome. Toots is from the UK, as you know. Helbes is from Germany. It's also hot here. Matthias from Finland. Wow. I guess it's not as hot as here in Finland, probably. No, we don't have air conditioning yet. I think this is something that we want to have, but I would say long term we're gonna have air conditioning next year in the studio, so we can work more days also in the summer. In the winter it is probably not going to be an issue here. We have pretty good heating in here, but we weren't prepared for the heat this year. Paul is from the UK and Jim is from Atlanta. Hello. Then we have Angus from South Africa. Welcome. And Draskul is from Texas. It's 38 Celsius here. Yeah, but it's also pretty hot, I guess. Yeah. It's super hot still. I guess it's not over yet. I think it's gonna be very hot for the next couple of weeks. We are going for summer vacation next week. We're gonna have a break for about 2 weeks. I have to do a lot of work on the house, so probably not going to have any time for the channel, but we're gonna be back, I think 20th of August, and then I'll continue working here, but I guess it's gonna be very hot and I have to work outside. So I'm curious how good this is going to go. But we have to do some bricklaying, we have to do some renovations, we have to do some painting. It's so much stuff that has piled up over the last 7 years that has to be done. So this is the perfect time. And it's school vacation, so we have to be at home anyways, mostly. I can't imagine living without air conditioning, that's what Straskul says. Here in San Antonio, we hold a bunch of world records for first in air conditioning installs. I guess, yeah, in other parts of the world, this is more common. It's Southern Europe, it's also more common to have air conditioning. Here in Germany, it's still not that much of a thing, but I guess since the summer this year is pretty extensively hot, then this is probably becoming more and more a usual thing. And in the office, especially like if you're working in the office, you can't work with like over 35 degrees, it's impossible to even think, right? It's crazy. So you can't really do a lot, except being outside, working outside is maybe easier, but like just sitting in front of a computer at 35 and plus, it is becoming very difficult. Okay, so I see for everyone it's a pretty hot summer. And yeah, today we have a little bit different perspective. I have set up my cameras a little bit different. So look at this. I hope this is better than last time. So we have this normal view, but that you can't see too much. And I have set my camera here. This is the other view now. So I hope that you can follow a little bit better what I'm actually doing from above. So nothing is going, hopefully, except of my head, maybe, sometimes. You should be pretty well able to see what's going on. And I can make this a bit smaller even, so just to have a little more of a personal view here. So that should be much better. I've prepared. Actually, I've prepared the next steps already. If you want to know where we stopped last time, we assembled the whole frame. It was in the Prusa manual, Prusa assembly guide. It was step number 2. I'm gonna show it here. So this was the whole part 2. We finished the y-axis assembly. Now we're going to do the x-axis assembly, which is looking like it's at least a few less steps than the y-axis. And then z-axis and e. I have no idea how far we're going to come today. But I guess we're at least, yeah, probably, my guess is that we're going to finish the z. Maybe the extruder, that's probably a little bit more work. Let's check it out. The bearings, I'm going to use the standard bearings. I've prepared them, so I've removed, or I've cleaned them a bit, so removed the oil from the outside. Then I've applied the Prusa lubricant to all of those here. Yeah, so this would be pretty much good to use. And the next steps here are to insert 4 of these bearings into the x-axis end idler and motor holder. So this is what we're going to do today, or as a next step. And we have to press them in from above. So the easiest way to do this is take one bearing and take this part and then pushing them in from the side. And then just pushing the part down on the flat surface. So bearing is essentially just going in. And then next bearing, so we want to push it in a bit more maybe. So we can set the next bearing in here. And then the idea in the manual, it says we should rotate the next bearing. So these little balls inside, which are the linear rail balls, they are rotated by 45 degrees versus the previous one. So we have a better touch point with the rails, so that all the sides are getting contact with the balls. So when we insert this, then it should be pretty much running very, very smoothly. So, and then we can push those. There is some point of resistance here. Then they should be pretty much in. So we are repeating this here on the other side. Same procedure here, pushing in the first one, using the table. It's pretty much in, so I'm just pushing it a bit more so I can just apply the second one, putting the second one in, rotating by, so that we have a little bit of an overlap here. And then pushing in the second one. So that's it. And we should be good so far. And there's this point of resistance here. So pretty much in the middle, should be fine. So these are printed parts and they come as a kit. So basically all the plastic parts in the Prusa kit are made with Prusa printers, and all of the printed parts are PETG by Prusa. So Prusa meant PETG orange. I've ordered the orange version of the printer. There is a black version also, but then like, it's pretty much boring, I guess. Halbees is asking, am I going to change the bearing? I guess not. There is probably better ones, but in the long run, maybe at some point I'm gonna exchange those. I did it for other printers as well when I think they're gonna hold up quite a while, and then at some point you need to swap out. Maybe then I'm considering the more expensive ones. The question that I have to Peter, what do you think about how much do we insert the bearings? Should we like have them equally distanced from both sides, or should we have them flush with one of the ends, right? I think that's what you're referring to with it should be on the ends. The question is like which ends? Down the lower end or the upper end? In the manual it says first pair should be in line with the top surface on both X ends. Second pair of bearings should be seated on the rim, close to the lower surface on both X ends. So it's probably pretty hard to push them. We can probably do this by using this little slot here, just by pushing them a little bit apart. Like they can move, I guess. So shouldn't be too complicated, I guess. So we can open up this a bit, just a tiny bit. So they come out. So the first one is gonna fall a bit. Probably going to fall down now to the lower end. So I can grab it here. So I can grab it here and push it, and then I'm going to push it to the other side. One down, one up. I hope so, at least. Push forward from the inside. We can do this. So it's on the bottom now. This one also. And now, how am I supposed to get the second one back? Probably with a very small screwdriver, just pushing it back. Taking this flat one here. So we can just push it up. There's a little gap here. Just gonna push the first one back again into the upper position. It's probably the best balance then. Here we go. Okay, so it's now pretty much flush on both sides. So this one is here and it's on the other side, and then let's repeat this. And make it flush here. I think this is looking good. Thanks for telling me. It was also mentioned in the manual. I wasn't quite sure how to do it because they say you should push both from top, and then at some point you need to like separate them again. Okay, this seems to work. Nice one. Halbis says, ANIT was my first baby. That's true for me also. My first printer was the ANIT. I guess I'm going to bring it to the studio. I still have the first ANIT A8 that I ever built. It's still working. So So we can, like once we have done this, we can absolutely compare these two printers. It's not fair, I guess, but it's like, it's interesting to see like how much of a difference it is in terms of the frame. It's like just alone having this all metal frame here is it's already a huge game changer. Good. How is it going with Firmware Factory? Very slowly currently. I'm making some progress, but it's not much. I'm currently working on something that is pretty much under the hood. It was suggested by, it was suggested to me by, I think it was, I don't actually remember who did. I think I was in contact with some people from the Marlin team. They mentioned to me, I think it was actually Scott, the Thien, who said it to me, that there is a feature in Marlin that you can export the configuration into the whole configuration that has been applied to a Marlin. You can have an ini file or a config file as part of the build process falling out of that, basically. And we did a little bit of a back and forth chatting, and then I had the idea to say, why don't we run an automated build for every single default configuration for a specific Marlin version, so that for all of these default configurations, for all of the printer presets basically in this specific Marlin, we export those configurations in this more computer readable format, and then make it available as an import into the Firmware Factory. So basically you can bring all of these, or you can bring any of your existing Marlin configurations from, I think there's just a version dependency that it's available since Marlin 2.0, I don't know what version. So you can bring that file, upload it into the Firmware Factory, and then start from that point. So you can just use, you will see what has been your changes towards the standard preset. So let's say you have used an I don't know, Ender 3 default configuration for Marlin. That is a set of configuration entries. Then you have changed a few settings. That is your changes towards the default Ender configuration. So when you bring that file and you select Ender 3 as your printer, the Firmware Factory will have the original extract from the Ender 3 default configuration. It will have your config file, and then it can basically detect what are the actual changes that you made to the Ender configuration and only show you those specific changes. So you don't have to see all of the Ender 3 default settings, which doesn't make sense. It's probably like 100, I don't know how many changed things, but it's gonna make a difference there and say, hey, this was the original Ender 3. This is your version, and what have you actually changed? And then from there, create the JSON that you probably already know from the Firmware Factory and show you that. So you just see, okay, I've changed 5 things. These are the 5 things that I've changed. And from there, you can continue using it in the Firmware Factory, and then you can also build and then re-export this configuration that Marlin creates for, I don't know what purpose, but probably for using it at another place or another time, whatever, to import it back again. So I think that's completely behind the scenes. You don't see that at the moment, but I'm working on this automated build process that builds all of the Ender. Like the thing is, the problem is to get the original default configuration files. You have to build all of the configurations. You have to basically run the build process for, I don't know, 150, how many configurations there are. And you need to do this every time a new Marlin version comes out. You need to rerun this build because there might have been some changes. So I want to do that now, prioritize that. I'm already halfway through, and then it's going to be available at some point to import. enough of that. Has nothing to do with this build. But I wanted to answer the question. Is the Prusa and the ANET the same thing basically? If you look close, this frame here, it's completely made of metal. So at first sight, I was thinking, hey, this is probably some, I don't know, wooden piece, a plastic part. No, but the whole frame is metal. And the ANET was plastic all over the place. Except this carriage here, and even the thickness, if you remember how thin the carriage for the ANET is. This is probably 3 times the thickness. So it is much more sturdy, stable. You need a proper firmware for this printer. I don't know. I'm going to use stock firmware for the time being. So let's continue with the this little process here. This is what we've just done. Next is X end motor tensioner assembly. So let's just do that from above. So just getting rid of this oily stuff here. So there is a piece here. There's a little slot here where we have to insert a very thin square nut. It's going in right here. And the square nut, there's a screw coming in from this side, so it's grabbing the square nut here. And this is part of the tensioner. So there is a special M3x30 screw that's going to go in here. This is the long one. Yeah, it must be. That's actually a little bit longer. No, that's the right one. Sorry. It's always good to have a table surface where you have some measurement guidance here on the side. So this goes in here. We're gonna put it in. Do not tighten the screw fully. Leave a 2 millimeter gap. Yeah, that's probably good enough here. We will adjust the final position later. Yeah, next step is bearing assembly. X and idler bearing assembly. So this is this part here. So we have a lock nut here that we want to insert here. Probably best using the table. That looks nice. Okay, you can and press it in, insert the fix 23H bearing into the X and idler. Here we go. This is the instruction part where we are currently. So I'm going to insert this from the top and at the same time inserting the screw from the side so I can lock it in. It's a bit finicky actually, having this part not falling out. But not too complicated. Try A8 firmware on it. Okay. Is the top camera a bit blurry? The question is always with this kind of camera, where is it focused? I guess we can fix this a bit better. Like if it's a bit blurry, we can fix that. We can, let me see, we can just have closing the aperture a bit. And then we are think we're back. What's the exposure? Okay. Maybe it's a bit more sharpened now. The thing is that there shouldn't be too much of a difference between this point up here and the lower end. I hope not. Good. So this is the tensioner wheel, or basically the idler. That's basically now in place. I'm not going to tighten this up too crazy. So we have, it's going still very easily. It's turning easily. That looks nice. So this is this part. Okay, not tightening it too much here, so it can still rotate freely. Now we are going to use the smooth rods. Take remaining smooth rods and compare the lengths. For x-axis, you need the longest ones. And then we have also 3 linear bearings, which we are going to we are marking the bearings. For which purpose? Wipe grease from the outer surface of the bearing with a paper towel. I did this already. I've cleaned them already. They are already greased. Additional grease has been applied to the inside. Position the bearing so that you can see the 2 rows of balls, like in the picture. Make a mark with a permanent marker on the outer surface of the bearings in the middle above 2 rows of balls. Use the same procedure for the remaining 2. Okay, so this is used to have the right orientation, probably also to have a little bit of a, yeah, so we don't want to align them. We have them rotated by, I think, 45 degrees, which is good. It's just there to make sure you're remembering where these markings are. I'm wondering if they put some kind of marker in the package. Otherwise, I will have to search for one. Let me double check. In the kit, there is an additional screwdriver here. But no additional waterproof pen, I guess. So I have to find one to do this. I will probably have some marker here somewhere. Yes. This should do. So, for you it's probably impossible to see this, but like in this little graphics here you see, or in the picture you can see it, what it means. They have these little ball bearings here, and we are marking this just at the top so we can see 2 rows of balls. So that's what I'm going to do right now. Meme Boy is asking, how much do you give the printer from 0 to 10? Well, this is my first Prusa i3. So for me, hard to tell how good this printer is compared to all of the previous ones I had. Can only tell you that, like, from a build procedure point of view, I think it's a very well explained manual, or the whole process is really good in terms of all of the details in the steps. So no questions for me are open. So from that point of view, I'm already pretty happy with the manual and the guide, and there's so much more. If you're still unsure, you can always go to the website, and there's videos also now. There's a Prusa Academy now, which contains all kinds of videos about how to use your printer and how to use Prusa Slicer. So a lot of information there. So essentially that is, so far for me, it's a pretty good experience. How good the printer is, it's by itself when it's built, probably very much depends on how good we are with following all the steps. So you can probably build this printer and have a very bad printer in the end if you're not following all the steps properly. So I've marked the bearings. Next step here is to gently insert or put these over the rods gently. So 2 go on one of the rods, and then the other one, the last one, goes on the second one. Here we go. And I have my markings here, so maybe you can see this. It's not sharp. Yeah, you can probably barely see the markings, but I have one here and another one here, and I will turn them a little bit just by 45 degrees so they are not like oriented the same way. Second one. Should be good. The holes in the printed parts must be clean. We need to insert the rods with bearings fully into the printed parts, so into these printed parts. Orientation-wise, it looks like this. So I don't want to make any mistake here. This is the idea. Insert the rods with bearings fully into the printed parts. So I'm taking this first part here on the left-hand side. I'm going to push the first rod in now, very carefully, until it hits the end of a hole, basically, where it's supposed to end. And I'm pushing in the second rod, also carefully, until we hit, like, we don't want to bend these too much, but on the other hand, it should be in. It's probably the idea. Second one is actually not going in completely, so I'm wondering if this is intended to be. It's probably not supposed to be this way, like probably supposed to be equally in length. Let's see if we can push it a bit further. So carefully. Not easy. It's not really going in much further. So here on this, there is a little bit of there's a hole here, probably to show you that you have reached the end. So from this side, I can see the rod is going in completely until it's shown here. Here, I'm still not seeing it on this end, and I'm not sure how much I can push it. I want to get it in without putting so much force on it. That's my problem here. It's not going in. Why not? Why is it not going in? Is it too tight? Don't want to bend it. No. There we are. Okay. So, needs a bit of force. And now we have equally distanced rods here, so they're pretty much aligned. The thing is, in the manual it says don't stress them or like tilt them. Don't tilt them too much. That's a bit of a challenge, I guess. And now we have the second side with the other end here that we're also going to push this whole thing in. Same thing here. I don't want to stress it too much. But I have to. Okay. Both seem to be inserted completely. Good. Next step. And my fingers are oily now, completely. Greasy and oily. So we did insert the rods into the plastic parts. Yes, they are completely inserted. So for me it looks like this on both ends. Now we are going to grab the motor from the motor kit. There is a little box here. That's the motor kit. We have to find the right one. That is for, this is the extruder motor. The X-axis motor. So all these motors are marked properly. So there's, for example, on this one here, you can see it's written here. Why is it not focusing? What's happening? Probably better now. Here we go. You see, here it says X-axis. So all of the motors are marked like this, so you cannot like exchange them accidentally. Good. So this motor plus the little pulley we are going to assemble now. So first of all, like we're going to turn the motor until we have the flat side here of the shaft. The shaft is going to face up in this case. This is the flat side of the shaft. We're going to push this over so that one of the screws is basically just aligned with the top of this flat side. And then we're leaving a little bit of a gap here between the pulley and the motor, just so it can rotate. And then tightening up. This is a smaller one, actually. So normally you can feel it here that it's facing towards the flat side. You can feel it. Tightening it up a bit more. Also from the side. And this should be fine. We can tighten it up more later, so we can just still like push it a bit to each side just to align it. Wim van Teffeln, he's from Holland. Hello. Good. What next? Well, next step is to assembling the motor, so probably fixing the motor to the X-axis That's what's going to happen now. And it's coming from the back side, and we're inserting 3 screws from the top. So that's what's going to happen now. Wim, are you actually from Holland or another part from the Netherlands? Because in Germany we tend to say Holland for everything of the Netherlands, but that's of course that's not correct. Oh, first time today that the Nightbot is doing something to the chat. Got some chatbot since our last stream, and the chatbot is usually doing pretty well in terms of finding explicit comments, deleting them. Last time it was pretty calm in that regard, but like the first time we streamed with, I think 2 weeks ago, there was lots of spam going on. I don't know why there was so much spam in that specific stream. It wasn't any different from all the other ones. So motor is fixed, but probably in the wrong direction. I just realized I have put it like the motor cable should come out to the bottom. No problem. You can just turn it. Just put it in the. Just need to turn it by 180 degrees. I wasn't seeing this, so this is the right direction actually. Always worth double checking this kind of stuff. So that is good so far. How's everyone doing? I'm just asking. You're watching me doing this, but actually chat is pretty quiet at the moment. So I'm wondering, what is everyone doing? Are just relaxing, watching someone else doing the work? What's going on, chat? Still here watching, yeah, I see. Now everyone's pretty like, oh, Daniel, I'm wondering what's going to go wrong next. Okay, so I'm pretty much sure. Hey, we've done step 13. It's time for some bears. So I love the gummy bears. Goldbeeren, Haribo whole Goldbeeren, that's what's coming in the box. So we can have 4, that's 10%. Yeah, I was just about to ask Südholland, because Südholland, there's North Holland and Südholland. And the next time we're going to Netherlands, we're going to Zeeland, which is pretty much close to the Belgium border. And that's when I realized if there's Zealand, then there's New Zealand. I didn't know, most of the time we don't think about where these countries are coming from, but since there's Zealand and there's New Zealand, probably some of the people from there founded founded this, gave it the name. I'm trying to finish assembling my own Prusa, so just watching an alarm if needed. Which step are you currently in, Peter? What are you currently working on? Which step? Good, we are done with the x-axis. X-axis is finished. Check the final look, compare it to the picture. So far, it looks fine to me. Just looking at this, I'm pretty sure that we completed it correctly. So this is how it looks now. I'm pretty sure that we've done it correctly now. Good. Let's go to the next step. Z-axis assembly. Preparing PSU. Okay, you're pretty far already. I see. And you're probably here, step 7. So I'm probably not gonna catch up to you today. Good. This is the next step. So we're like the vertical axis, that axis. We're gonna assemble this now. We also need the pliers, Allen keys, and now let's figure out which parts we need. So all of the plastic parts here I'm gonna find, probably very straightforward. We have some, like, the nice part about this kit that all of the parts that are for a specific step, like the Z-axis assembly, are coming in a separate bag, right? So you see here, this bag is labeled Z-axis. These are the plastic parts for the Z-axis, so you can't miss it. So I'm sure this is all, like we need all of these parts. These are the first 2 parts that we need. There's also another plastic bag here. I'm gonna throw away some of the stuff now that we don't need anymore. There should be another little bag here. This is the second one. It's also labeled Z-axis. That's where all the screws are in. So you can't really mistake anything or confuse something. I think it's virtually not really possible. So these screws actually look like they're all the same. Yeah, they're not very much. It's just a few ones are different, but they're mostly the same. Okay, so we will need to okay, what next? Place the printed parts next to the frame. There is markings on the plastic parts. Seems to be marked with L, marked with R, and then we need 3 specific lengths for the screws. So M3 by 10. Yeah, this is the smallest actually, shortest one. 3 times. Good. Where are we going to place them? Here we go. So just next to the frame. So I'm going to put the L part here. The right one on this side. Prusa symbol is here at the front, so we're oriented correctly. Tighten each printed part. Don't use excessive strength. So the way how they are mounted is like this. So facing with the R towards the frame, I'm going to insert these 3 screws now. Let me briefly fix something here. Okay. This is fine. Nice part about having a metal frame is that you also have like the threads are already in a part of the frame, so you don't need, like in the A-knit build, you need all of these nuts everywhere, and not even they're not bothering even to use lock nuts in the A-knit A8 build, just using regular ones, which are yeah, sometimes they just release or just become loose, so the whole frame starts wobbling. So what my suggestion is at least to replace the original ones on the A-knit frame with the lock nuts. So motor holder 1 is fixed. No excessive strength during tightening. Yeah, because this is a plastic part and we don't want to overdo it. And we should, where's my magnet? So let's do this. So we magnetize the screwdriver for this. It's a bit better, easier. Makes it much easier. Here we go. So, Layden says, while watching your stream, I'll install my dual Z-axis kit in my Ender. Nice. I still have a dual Z-axis kit for the Ender 3 V2 in my basement. Do you want me to do this on the channel? To the Ender 3 V2? Just let me know. This could be something for the next stream once we finish this printer. Still want to do it because I think it's gonna get my frame much more stable on the Ender 3 V2. So we can do it here on the channel if you want. Ah, Ali Mohammed, you're here. I think you have been here last time also, right? Welcome back. Nick says I was also thinking about getting a dual Z-axis screw for my Ender, but I don't know if it's worth the investment. I think it's gonna make a difference only if you're printing parts that are like wider on the one hand, so which fill the whole print area. That's going to be a little bit of an improvement. if you have a pretty heavy print head setup, like for example, you changed to a direct drive. I've done this on my Ender printer, or for all of my Ender printers now. So the print head is much heavier now for all my Ender printers. So I think from that perspective, it makes sense to have dual Z-axis screws for direct drive if you print something that's really filling the whole print area, and if you print something that's pretty high. So I think if you're going for maximum print volume usage, like I'm doing with my computer case prints, I can imagine that it's gonna make a slight difference in like the layer height consistency for these bigger parts. And if you're printing faster, also quality-wise might be a little improvement. I mean, it's not gonna be like crazy improvements, but it's also gonna reduce the stress on your like Z-axis or X-axis wheels a tiny bit. So like when the print head moves to the further extent, it's gonna be less of a stress. But I guess it's just a minor thing. It can make a difference. Some people say it's a huge difference, but I think it's like it's gonna be some noticeable difference in special prints or for specific types of prints. Revealo says, I tried to build an AM8 with SKR 1.3 using your video. Sadly, I had to sell it as spares or repairs. Seems the code has changed significantly since you did the video and could not get it to work. That was a while back, I agree. I still have this printer. I still have it in the very same setup. I'm considering to disassemble it and reuse the parts for another build. So I'm probably not gonna like put too much work into that printer, except maybe like rebuilding it with another frame or like just reusing a few of the parts and maybe replacing the mainboard, something like that. Daniel Reuter, technically the plastic will over time creep out under the screws, so you will have to over time tighten the screws anyway. At least that's what my textbook said. Yeah, that's the point. That's why I like the metal frame a lot more. There is also a metal frame for the ANIT A8. It's called the Tatara Frame. Essentially, the Tatara Frame is very similar to this one. It's very similar in terms of how it looks like. It's not using these extrusions here. It's like more all these metal sheets. That can be an option for like making the ANIT much better and making more like a Prusa, right, in terms of the quality. So I wonder if anyone has done a dual extruder setup using two BenQ H2s. Yeah, maybe someone in the audience has. Like probably get to them. Let's go for our next step. Placing the Z screw covers. Okay, so we have two motors here in the motor kit, which already have the Z screw attached. Essentially, first one here, and this is the second one. So they are pre-assembled. They have different cables, so they're for different sides of the printer, obviously. So I'm gonna figure that out. Right and left, so already marked here. So there's already like says here, like this is Z-axis left. The other one's also Z-axis right. So what are the covers for? Remove the trapezoidal nuts from the motors. Don't throw them away, you will need them. So we're gonna remove these nuts here. And then we're going to screw on the covers. Okay, let's remove those first. covers are part of this Z-axis back. So we're going to put on the covers. Are they also supposed to be screwed on? Or just push over? Oh, they are kind of tight, so it's not as easy as the other, the original nuts that have been on here, but it's probably going to be quite a way down. Good evening. If you do a dual axis setup, you need to check the cabling of the motors. Yeah. Please remember to put the caps before mount motors. I'm not sure what you mean with that. Peter, what are you referring to? To put the caps before mount motors. Do you refer to these little motor caps here, these little covers that I'm just applying? Oh yeah. This is the one. Okay, I'm doing it right now. So, second cap going on. I'm applying the second one now. The covers should be screwed fully to the motor, but not too tight. Yes, so I'm bringing them down to the top of the motor as far as I can get it, but they shouldn't be like super crazy close to the motors, so they can spin. They're probably there to protect the motor from dust, something like that. It's probably my best guess, or some grease or something. So we're pretty much there, not too tight. And this is looking good. Now probably we are going to reapply. Are we? Oh, probably not yet. We are assembling the motors. So we have Z motor left, which is the one with the shorter cable. It's going to the left motor holder. The one with the longer one is going right. Then we need 8 times the M310 screw, 4 on each side. Good. The cables are facing in which one? Motor cables must be oriented towards the frame. There is a small cutout in the frame on the lower edge for each cable. So, cables facing to the back, and then we are just pushing it through here. Esther Hugenay, would be nice if you could do a live session on how to mount LED lights to the printer. Nice one, yeah? I would love to have LED lights on this printer. Probably looking pretty awesome, actually. I like the idea. So let's fix the first one. First motor. So far, so good. Yeah, I'm pretty excited still to do this because this printer was actually in my basement for the last 8 or 10 months even. I got it from Prusa. I ordered it as a Black Friday deal last year. I think it included another coated plate as a freebie and also another spool of Prusa PETG. So there was some bonus stuff coming with it. Was for essentially the same price. So I said, hey, why not try out a Prusa? Also, in terms of it makes sense for the channel. Also makes sense for my future plans to do more print shop work. So basically printing stuff for other people, doing more projects that are more like requiring longer print times, a reliable printer, stuff like that. So that's why I got it in the first place. I never got to do it in the last 10 months. There was so many other things to do for me. And I also needed to find my direction, I think. So just personally telling you that currently I'm a bit struggling with like where to go next with my all of the printers that I have. I'm currently thinking about actually reducing the fleet to the essential that I need to do like these print jobs to print the projects that I need. And all of the other printers that I'm currently maybe didn't even assemble yet. There is a few. I will get rid of those printers at some point just to make sure that I'm focusing a little bit better on the things that I actually want to work on, except like I'm not going to do a review so much, probably more these kind of videos like this one here, because I really enjoy doing this live and then enjoying just to enjoy the hobby and just enjoying the things that we do here. So, does the main board support RGB LEDs like the SKR boards? Honestly, I do not know if this is something that the board supports or if we have to do this externally. So, Prusa is very basic in terms of what the additional ports regarding the additional ports, that if they have any, because they are very much focusing on like this being a tank for the job and nothing else, nothing fancy, so to say. So if you want something fancy, you probably have to use a different mainboard also on this printer. But we will see. I'm going to make sure that I'm not telling you something wrong here. I do not know, honestly, which additional ports we could use for this. If there is any, probably there's going to be a possibility. Let's see. Good. Tutankhamun, I built a cube chassis printer with 2020 and have fitted LEDs inside the slots so they are hidden from sight, which sounds awesome. Sounds awesome. It's probably looked like you can post a picture, or no, probably not here, but can you? No, you can't. But anyways, you can post a picture in the Discord channel if you want. If anyone is not here already in the Discord channel, Tutankhamun, you can probably post a picture there. Probably looking awesome. So let's assemble the next thing, trapezoidal nuts. For the following step, preparing the nuts. Okay, I've got them here. We have 4 M3 18 screws. These are the longer ones. We have 4 nuts, which I also have here. Turn the x-axis upside down, insert nuts into traps on both x-ends. Wondering what that means. Ah, here we go. I see where this is going. Okay. So we need to insert those nuts here. Probably easier with the pliers. There is a tiny slot here. And this is not easy. Not easy with big hands. But yeah, we can do it. We can do it. So I'll try to show it to you. Here, where are we? Here is a tiny slot for a little nut that goes in right here. And then the screw is supposed to come from the bottom, but this has to be pushed in. So to do this. Bit challenging. But with some pliers, it's probably possible. Okay, let me see if this actually works. Is it grabbing? Yes. Looks good. Same procedure on the other side. Come on. Getting this tiny nut here in the slot is not an easy job. It's not an easy job. Okay, so it looks like it's in. Not fully, at least. Need to push it a bit more. Here we go. So, double checking. Is it grabbing? Seems like it's not in there yet completely. Here we go. It seems to work now. So the nut is in the right place. We have two more to go, which are easier because they are just sitting here on the outside. So just sitting here at the corner of this frame part. Still not easy to get them in. And we can use our special tool. To push them in. Good. So they're sitting in place now. Yeah, I think Tutum Karman, you're teasing them too much. You have to show them the pictures now. I'm gonna open Discord. Let me show it. Did you post something on Discord? I'm just opening it up and I'm gonna show briefly in the stream. I just have to log in myself. Yes. Okay, so did you post something? Just looking for it. Which channel was it? Project Showcase, maybe? Or was it Ender3? Okay, just post it. Like, Toots, just go ahead, post the pictures. If you have some, post them in the maybe in the Ender3 or in the Project Showcase channel on our Discord channel, and I'm gonna bring it up for everyone. Yeah, maybe next time then, or just do it later if you have the chance to get some pictures of your printer. I would love to see that. Sounds awesome. So we are going next step, we have the nuts inserted. Everything is in place now. And then we are screwing in the trapezoidal nuts using those little counter nuts. Good. So first one from the bottom, I guess. Yes. First one, second one. So here we go. This is the essentially where the Z-axis rods will go in, just right here. And it's driving the whole frame up and down. Oh, that's my magnet. Good. Second one here. Good. This looks about done. And now, next step looks like this. We're gonna, what are we doing? Oh, I see. So we're pushing this over the frame now. Carefully slide X-axis on the trapezoidal lead screws. Okay, so we're starting here, pushing this over carefully. And we're rotating the screws simultaneously, as they say. Okay, let's do this. So getting this over. And then once it's on, trying to rotate. Once is it grabbing now? Okay. So we can now get it down. Looks good to me. How far? Probably not too far. Not required. So it could probably still be make sure the top smooth rod and the lower edge of the frame are parallel. Like, how can we make sure? Probably we can. Okay, we can use this top rod here to align. So I'm gonna have to look on from the side, checking like whether this is parallel. So I'm looking for this to be parallel with the upper rod. Just from the side, making a tiny, tiny gap there. And then checking that this is equal on both ends. Well, we can adjust that later as also just to make it perfectly equally distanced. For me, it looks like it's good. So the gap here is pretty much the same on both sides. Good. And then we are taking these two remaining rods and pushing them carefully through the bearings from the top. We're not making any of the bolts falling out. Okay. Very gently. So both are sitting in the slots now, pretty much firmly. It looks good so far. So we're sliding the axis on, rotating the screws. We're making sure the top is parallel. Be very careful, gently inserting the rods. And then now placing the top parts. These are the remaining 2 plastic pieces from this bag. And we are now placing them here on the top. There is some places to screw them in, I guess. Yeah, from the front. So once again, there's a left side here. I'm going to push this over gently, and then I'm securing it to the frame using 2 screws. Same on the other side. Oh my goodness. So, even though I have a magnetized screwdriver, it's not easy to get those screws in. Probably have to insert them a bit before I do this actually. But it's good. It's working now. Okay, this looks about right. Do the same on the other side. This time inserting the screws first. Slide this over. And now we are like making sure this is making sure the rods are equally distanced from the frame on lower end and on the upper end. So nothing is getting out of place. It's supposed to be at a very distinct distance. And this is making sure that this is happening. Good. Looks nice. Looks sturdy to me. So probably you can see it from this side here. So let's have a look. This is how the frame looks like now. We've done the slider basically with the motor and also the belt. Z-axis is done. X-axis is almost done. Of course, we need now the whole assembly here for the extrusion system, but like from this, it looks already pretty nice. It starts looking like a Prusa printer. Looks becoming kind of familiar now. Okay, so we fixed that. And we have another break. We have another Haribo break. Let's see how many can we eat now. We can eat 10%, which is another 4, another 4. Any anti-backlash function there, they look very solid. Yeah, it looks like pretty solid. I can agree. You have posted a pic. Where did you post it? Did you post it in the showcase? Oh, here we go. Gonna show you a picture, although it's a bit blurry. But this is Tutankhamun's printer frame with the LED lighting. It's a bit blurry, unfortunately, but it looks nice. I can imagine how how this looks in a completely dark room. It's probably awesome. Looks pretty decent. So guys, if any one of you didn't join the Discord channel yet, good chance to do this right now. I'm gonna post you the link. Almost forgetting like where to get the link, because it's supposed to be the same link all the time. But let me give you the link. Here we go. Discord link. This is our Discord server. And you want to join, just go ahead, click on the link. If you don't have a profile yet, you have to create one. And then you can join any Discord server in the world. Ours is just one of millions. No, but ours is a nice community of people, like-minded people, chatting about different topics. If you look at the channels here that we have basically we have a notification squad. This is the first one where always when I post a new video or like this live stream, gonna visible here. And then we have channels for all kinds of topics. Modern firmware, different mainboards, different printers from like ANIT, Creality, Elegoo, Prusa, and then different various other topics where people are discussing stuff. So just feel free to join, it's free. And I also welcome everyone who wants to answer questions there, who's like gonna give their expertise away and just joins this. Like if you have specific knowledge about something and you're willing to join, there's a few people who ask questions. If you're willing to answer, I'm super grateful to have you here. I can't do this without the community because otherwise it would just be me, and I have some awesome moderators, Julian Carmen being one of them. I guess it really depends very much on the people, and without you guys it's not possible, right, to run all of this and like to have a community like this. So that's why I'm enjoying it so much. But there's so many other like-minded people out there who like to do this stuff. Okay, just want to see where are we going next with this assembly. We've done the Z-axis, and now we're going for the E-axis. Pretty difficult. Like difficulty, very difficult, very difficult. I can imagine. So probably we're gonna start just right away so we get some progress here. Not sure how much we're gonna finish. My best guess is that, oh my goodness, this is a long chapter. It's like 72 steps. Oh my goodness. This is pretty long. Okay, anyways, let's try to do some steps of this extruder assembly. Daniel, yeah, thanks for joining the Discord channel. So I'm just gonna start digging out all of the parts for this extruder assembly. Let's see what we need. There is this here, it just says E-axis, all of the Yeah, all of the screws, basically some belts, some interesting looking parts. Bondtech. Okay, I see there's a few parts here. Metal parts, probably the motor itself, extruder. Is it? Yeah, it's the extruder motor. What else do we have here? This is empty now, I guess. Is it? Okay, there's a spare. Spare part, actually. There's so much waste now. Good, what next? MK3S plus extruder. Adapter, printer, extruder idler, lever, cover. That's supposed to be part of it. Power supply? No. Spool holder? No. What is this? This is also part of the E-axis. Some plastic parts, carriage, motor plate, covers. Lots of parts. Lots of parts. What else? Let me check. LCD? Not yet. Not yet. Not yet. What else? Extruder box. What's in the extruder box? Oh yes, here we go. Here we go. So, the hot end, cooling fan for the parts, and yeah, this is the cooling block fan, the IR sensor. I think that is probably filament sensor. Yeah, probably filament sensor. So, few things here for the extruder. And then we have another little box here, which is this is probably the main board. Electronics. We need that later. Yeah. Bunch of stuff here still. I guess we have everything that we need for this section for now. Pretty much all the parts should be here. Good, let's start. Let's start. Few tips. Most important and hardest chapter, you see. This is like, until here, it has been easy. I don't believe that. But the thing is, I think the most important here is really to really dig out all of the parts and just make sure that we're not confusing stuff here, and then go step by step. Even if it's really hard, I think it's doable. It's absolutely doable. Good. The bag with fasteners include M3x20 and M318 screws. Make sure you won't mix them. Yes. We have some ruler here so we can always double check. Keep the magnets apart in a sufficient distance they can break each other. Yeah, I can imagine. The hot end needs a shorter PTFE tube compared to the M3S. What? How to trim? What's the point? This guide is dedicated to the PTFE trimming for original Prusa printers. More multi-material trimming guide. Is it not trimmed? Seriously? I mean, why is it not the right length? Mm-hmm. Okay, this looks a bit longer. So I'm wondering whether this is already done or not, because this printer came as a pretty much a set kit for MK3S Plus. So I'm wondering, is this already done or not? I'm not sure. I will have to double check the length then if there's any doubt. So how does it look like? So you see, this is the tube that comes with the hot end. And it was like inside of like inside of this hot end already. Like when I insert it, it's pretty much like there's a little bit of an overlap here. It's extended, extruding or protruding by what? Probably, I don't know, 8 millimeters out. So the overall length should be, according to this manual, how long should it be? It should be 42.3. So let's double check. How long is it currently? 42.3. Well, that looks right to me. So, and like according to my ruler here at the bottom, it is coming in the correct length. That is good. I was just thinking, like when I buy an MK3S Plus kit, my expectation is that this PTFE is already cut to the correct length. It is, so we don't have to do anything here. Wasn't sure about that. Okay, so let's go for the next step here, which is the extruder body part preparation. I'm gonna get this part first. We have a few more parts here, adapter and the lever. Adapter for printer and lever. So here we go. These are the parts. This is the body. And these are, by the way, these are all printed parts that are made from PETG. And you can also, like, if you decide to get a kit from China, it doesn't, most of the time it doesn't have the printed parts, so you have to print these parts yourself. So you have to have a printer that's capable of like printing these with some rigid material like PETG or ABS maybe, and having that pre-printed is going to save us a lot of time, of course. So what's next? Okay, then we need some nuts, bolts. Okay, for the following steps, please prepare M3x18 screw. Now we have to double check the length of the screws because it's different ones in the back. This is a 10. This is 18. So this is 10, this is 18, and there is also longer ones. So this is supposed to be the same length. I guess there's also 20, M320 length. Yes. But these are, like, they're easy to distinguish. They are a bit longer. Good. How are you doing, guys? Wim van Tevelen from Arnhem, Gelderland, 20 kilometers from the border of Germany. I see. Daniel is 126 kilometers to, that's 20 kilometers, and that's how far I'm from Germany. Oh yeah, so you're both from the Netherlands, I remember correctly. Okay, I'm gonna be in the Netherlands quite soon, as I said, in Zealand, just to visit the place. Of course, I got a friend in The Hague. That's I'm probably gonna visit soon. Just looking forward to that. Just doing visiting some friends. So we need the magnets. We need both magnets here. We need M18. Now we have one of those. We need a M310 screw, which is this one. We need M3NS and M3N nuts 2 times. So one normal, 2 normal nuts and 2 square nuts. Here we go. A steel ball. Tiny, tiny steel ball. And the magnets. So next up, we're going to insert taking the body here and inserting the M3S nut. M3NS nut. Inserting it here into this tiny, tiny slot. Leiden is still mounting his dual Z-axis kit. So you didn't make so much progress, actually. I'm making some progress here. I did the dual Z-axis already on this printer. I'm done with that. So this was the small nut here, the flat one that went in here. Then we have 2 normal nuts going in here using our special tool to press it in. Why is it not moving in? Is it? Oh, it's going in. It's going in. Pretty flat now. This looks good. First one is done. Second one is done. Pretty nicely in, I would say. Good. So these are fixed. Blah, 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 blah. Okay, what we're inserting it. Ensure the correct alignment using the Allen key. Secure the nut using an M3x10 screw. So we're gonna try out if that works. If it's in correctly, if it's in far enough so far. Is it? Or do we need to adjust it? That's why we use the Allen key. The Allen key is pretty useful to find out if it's correct. If it's in a position where we can actually insert the screw. Where is it? Here it is. So that's a bit too small. Okay, so for me that looks okay. For me, that looks like we should be able to use the screw and put it into the nut now. Yes, kind of works. Yeah, that looks good. This is for the Pinder probe. This is going to go right in this hole here. Next one. Okay, so the next square nut goes in here right at the top. There's another slot here. It's not yet really in completely. Push it a bit further, even more. And double checking that it works. Yeah, good. This is the red step. Take the smaller magnet and insert it carefully in the FS lever. So there's a very, very small magnet. And there's a plastic lever where we are going to insert this to. This is for the filament sensor. So the filament sensor is part of the extruder. It's inside. So it's very close to the actual extruder. So it's easier for the filament to go in because they are using this little this little metal ball to just push a filament who's going to push the ball to the side, and that's why it's, from a construction point of view, it is very easy for the filament to go through the sensor compared to other solutions when there is a really a switch and has to push much harder. Okay. So the magnet is going in this little part here. Gonna push it a bit more. Very tiny. Hard to see for you. Here's the magnet, and this is the small lever for the filament sensor. Good. This is one. Double checking that I'm not missing anything. And then we have the lever mount. That small lever is going here inside of the extruder body, and this is where the lever is going to sit, and the filament is going in from this side, and the lever is going to be pushed to the side here, and it's going to be detecting whether there's filament in or not. Good. We need an M318 screw to fix this. Double checking that I'm getting the right one. Yeah, this is the M318. So we're securing this lever just to the point where it's still able to move, but it's also at the same time it is secure in place so that it doesn't come out. Just doing it a little bit more, then I'm gonna release it. up to the point where it's going to move. Here we go. Good. Insert the bigger magnet in the extruder body. It will stick out. Oh, I see. So the idea here of the filament sensor is that these two magnets are going to push one another to the side and not going to attract, right? So the lever is pushed to the right. So this is how it's supposed to be. We have the lever here, and if we push the lever, it's gonna just come back into the old position because the magnets are pushing one another apart and they're not attracting. That's how it's supposed to work. Good. That's done. Layden says he's rewiring everything. So you're still on the dual Z axis for the ender. I'm curious to see it done in the end. Okay, steel ball assembly. We have this tiny piece of plastic here where we're going to have the steel ball in. Here we go. Remove the ball, clean the inside. Now it looks good. The ball is perfectly fitting in this part. Place the printer part together with the steel ball in the extruder body. See the rounded protrusion on the printed part. I see. It's going, where is it going? It's going in here. There's a tiny slot here. And this is fitting in here, right here. So I see, so as soon as filament, like you can't see, this is very hard to see actually. But here is a tiny hole, that's where the filament goes in. There is this tiny ball here, and then as soon as the filament goes in, it's pushing this lever. Pushing this lever to the side. So the ball is right here. Filament goes through and pushes the ball out and then pushes the lever. And that's triggering the sensor. Pretty clever design, same design as on the Prusa Mini when you are going for the Bondtech ITX. Pretty much the same design there. And it's super reliable, it's super easy to use. Not hard resistance for the filament, it's very easy to push it. That's why I like this kind of design so much. Good. Now next, the extruder motor parts preparation. We have the motor, the motor plate, which is here, motor plate, and two M3x10 screws. Double checking the length. Yes. And we have Bondtech gears. I have all of these parts. There's a set of the Bondtech gears. Make sure you have all the parts you are using correct ones. Green, use now. Bondtech gear with a set screw. If the screw is out, gently screw it in, and then use later Bondtech without a set screw. Bearings and shaft keep somewhere safe and they tend to roll away. Good, okay, I'm just getting this one out with the set screw. Got all the parts here. Bondtech gear assembly. Good. Okay, so we're going for it. I'm going to zoom in a bit for you. So we're going to get a better view on this very tiny stuff actually. Good. So how is this going to work? Take the extruder motor plate and secure it using 2 screws. Here we go. How's everyone going? I'll be heading to Cologne to hopefully go to the Michael Schumacher private collection. Good idea. Good idea. Yeah, and there's so much stuff to see in Cologne. Like, it's really worth visiting the city. So we're going for the extruder motor shaft. It's going to face to the left so we can see the flat side. And we have this Bondtech extruder gear, and that's going just over. So we probably have to release this little grub screw a tiny bit so we can do this as one of the smaller ones. Good. Rotate the shaft as in the picture. Flat part must be faced the direction of the arrow. Slide the gear on the shaft. The set screw must be facing against the flat part. There's a channel, so we need to make sure that we are aligned with the channel. I see. There's a little channel here in the plastic part, and the gear channel must be aligned so we can like look straight through, and there is nothing in the way. And that's pretty much it here. Looks good. Can we double checking the adjustment? But this looks really basically perfect to me. Good. Tightening that up. Okay. Trying to Arrow X Coder is trying to repair his i3 Mega. Oh, another nice printer. I'm curious to hear how you like it. Good. We're here. Basically, we are adjusting. I've done this adjustment so the filament path is clear. Filament can go through here, and it's aligned with this little channel here in the extruder gear. Alignment will be done, not like tightening it just yet. Yeah, just not that tightened. Bondtech gear alignment. Take a piece of filament. Okay, we need some filament now. Got some spool here. And I am trying to insert it. So we'll take the sample filament that's coming with the printer. There's my knife. Here we go. Oh, nice silver filament coming with this printer. So let's take just a bit of the filament to test the channel. I don't know how much. Yeah, piece of the filament, whatever, not too long. This is actually not a Prusa spool, I see. It's probably some normal PLA filament that they give you, but they gave me an original Prusa spool on top, so I'm happy. You still have another printer, I see. So just double checking the sensor here. It works pretty fine, so just to show you this. This is the way how the filament sensor is supposed to work. So here we have the little opening for the filament. If we push it through, this ball gets pushed to the side and it pushes the small lever, and then it's going to trigger the filament sensor. And here on the extruder motor, we're testing the filament path now. Where is it going in? It's going in here. So it's supposed to go in here and it's supposed to go out a clean way without any big resistance, I guess. Place the filament along the path and align the gear properly. The filament will be always slightly bent. Use it anyway for the initial alignment. For me, it looks like pretty nice. Tighten the screw. Yeah, well, I'm pretty happy with that so far. Let's say it can take a tiny bit of an adjustment, but it doesn't have to. For me, it looks good. For me, it looks like the filament is really going in and out pretty well. If I turn this, it's transporting the filament as it should. Looks good to me. For a final check, replace the filament with an Allen key. Keep in mind, it's not the same diameter. That's good. But for me, that looks fine. Looks pretty straight. Tighten the screw slightly to temporarily fix it. We will make the final check and tightening later on. Be careful, you can strip the thread. Yeah, but don't overdo that. Don't use any glue to fix the screw in place. So next, extruder cover part preparation. Extruder cover, we will need this. That's the part. An M3NS nut, so that's a square nut. And then we're sliding this all in. Good. Leave the hole on the arm empty for now. We will use it later while assembling a print fan. Okay. So leaving this empty. Hot end parts. So take out the hot end. Then we need an M340 screw. M340. This is one of the longer ones. 2 times, and 2 M310, just short ones. We will use 1 M40 later on, keep it around. Yeah. Don't cut the main zip tie on the hot end cables or remove the rubber band. It will make the assembly easier. Good. Hot end assembly. So we're taking the part that we just pre-assembled and inserting some screws here. Just posted pictures on Discord. Hey, Layden, let me bring it up on the screen. Which one? Which channel? Ender 3 probably, huh? Or Ender 3v2? Where did you post your pictures? Which channel did you use? General channel. Oh, okay, I see. Here we go. Here we go. Okay. Let's show it to everyone. This is your cable management for the Ender 3. Yeah, I know Ender 3 is pretty much, there's so many cables going different directions. Pretty hard to do it in a clean way, but it looks okay to me. I see you did extend some of the cables here using extension cable. That's always a bit dangerous. I would try, in my case, I'm always trying to replace the whole cable, not extending it, but getting a long one, just to have it in one piece. It's a bit safer because these contacts can get loose or like just be a little bit unreliable. So don't forget to grease those connectors. This is the assembly, tilted, but yeah, dual Z axis on Ender 3. Looks good. So tell us later, maybe in the Discord, how you're doing in the Ender 3 channel, how your results are going to look like, and if you see any improvement. Thank you. Okay, so let's continue. Where's my guide? That is my guide. So we have 2 screws here inserted in this extruder part. And now we are inserting, okay. Screws might be missing. Place the hot end next to the extruder body. See the grooves in the printed part, which are in the shape of the hot end. I see. So, like we're putting this in, and it's fitting in right here. There's like just some grooves that are perfectly fitting this. So now the extrude, like the hot end sits in this printed part. Fits in pretty perfectly. Good. What next? Correctly placed hot end cables will be pointing to the left. Okay, for me that looks fine. Then assembly, in order to protect the cables, it's highly recommended to use a box. Okay, we're gonna put it on a box, so we're not gonna like bend the cables too much or in any wrong direction. So what they suggest is like having this hanging down for whatever reason. So now we have this hot end set up right here. Place your extruder body with the hot end on the box. Make sure the cables are on the left side and pointing down. Place your finger temporarily on the longer magnet and place the extruder motor assembly on the extruder body. protect gear might pull the magnet out while assembling parts together. So this is how it's supposed to look like. So we're putting this on. And it needs to come together in one piece. So, yeah, looks good. So I put it on top here. We're putting these two pieces together. Still looking good so far. So we can still align this, having it pointed to the left side. So far it looks good to me. This is one piece now, so like basically all the extruder. The counter gear is still missing. Like we're only seeing one side here, which is like the first gear, and the second one is gonna come here. There's a lever that's gonna push the second gear down here, so it's gonna have the pressure on the filament from this side. Good, so far so good. Just double checking that have everything aligned. Okay. Now we have the cover on the extruder body. Again, make sure that all three parts are properly aligned. So I'm going to place the cover on top here. Hopefully having it in the right orientation. Yes. So far looking good. So we're inserting two M40 screws from the top. So fix this part together. Daniel, it's in the general channel. Yeah, you found it already. When do we see a Banshee? Oh, yeah. I'm not sure. I think the assembly is going to take about a bit still. So I have pretty much assembled this piece. Looks good to me. Good, so I'm just wondering how much the second screw is supposed to go in here. Probably pretty much aligned, pretty flush. They are slightly longer than the thickness of the entire assembly. Be careful. Okay. Yeah, I get it, I get it. Understand it. I think I'm fine so far. It's like assembling everything. So to put it aside, we're gonna need it later. So this is the extruder. X Carriage parts preparation. Okay, next step here, step 15. I think I'm gonna do a few more steps until we call it a day, and then continue next time. For the following steps, please prepare X Carriage. Okay, got this here. M3 TN M3N nut, so the normal ones, and an NS 2 times. We have 2 times the normal ones. We have 4 times the square ones. That's everything in this bag. And the IR sensor cable. Oh yeah, where is this? I hope I'm not missing this. Where did I put it? Here we go. It's in the additional bag. Here we go. IR sensor cable. Good. So the X. A nice instruction here. We are assembling this, and I think use a screw for the following nut insertion. That's an order. Seriously, use a screw to pull the nuts in. Both have to be properly seated in the X carriage. I get it. It is not very easy to get those in place because they're very deep in. So probably I have to use a pretty long screw to get them down, to actually pull them in. I'm curious how this is going to work. Yeah, but this is exactly the method. Like we have a long screw here, we have the nut. It's going to get pulled down into its cavity, into the sink, and then there it's going to stay. Done. And then now we can remove the screw again. Repeat this on the other side. So one more time. I'm getting the screw in first. So then I'm getting the little nut on the top. And I'm just tightening it up so it's going to get pulled down slowly but consistently, and then it's going to land in the slot, and then it's going to be pulled in. And that works pretty well. So now I need to receive my direct drive carriage plate, then I'll be able to print, test the DZ axis, and everything is working as expected. Also using anti-backlash nuts for both axes. Yeah, Layden, I think you're pretty much done in that regard. And I am also pretty much exhausted with this, with these first few steps. It is quite a journey. It is quite a journey to do this. There's so many more steps to go. I think we're just halfway through this part of the extruder build. It consists of a lot of individual pieces. So I would, actually I think I have to double check one more time why this second screw isn't perfectly in. Not sure why this is the case. I think the nut is kind of broken. For me, it sounds like. It's not really working as expected. Yeah, the nut is probably broken. I don't know. Not too bad for now, but it's It's a pity. I think I need to fix this next time. For whatever reason, I think we have to replace one of the nuts here because they are probably the thread wasn't the best in the beginning, and I didn't realize that when I started tightening it up. So I have to get it out now. Anyways, I think I can do it. Not too bad. I mean, this happened to me on the ANET multiple times because the nuts weren't too good in terms of the quality. It somehow worked, but yeah, this can happen if you have some nuts where the threads aren't perfect and then you realize it too late. Yeah, some pliers will do, and then just cranking the nut out and then replacing probably both the screw and the nut is going to do it. That's it. But anyways, I think it's even going to work like this. Just when you have to disassemble it, next time you have to replace it. I guess it's not too bad. Okay. Yeah, I have to clear the threads, but it's like didn't check the nut before I inserted the screw, and then it's like kind of it was a bit hard to insert it, and then it was too late. I guess it was already done. Can happen. Happened to me on other parts, not with this build, but with other builds, and then you have to figure a way how to get it out. But it's possible. Good. I think I'm gonna leave it here. So we're halfway through the extruder assembly. I think from the step perspective, we still have we just did 17 of the 72 steps. So we are like step 17 in this guide. Just posting it in the chat. Robin is still watching. I'm just gonna tell you that I'm gonna end it. I want to thank everyone who is still here, who wanted to watch this, who wanted to join me. We are going to continue at the same at this very point of the build process. Next time here on the channel. Anyways, we're going to have a little bit of a break now. We're coming back 20th of August or something like that. Let me check. So when we are going to be live one more time, like it's going to be like 22nd. So going to have a 2 weeks break now, working on other things in the house. So I wish you a few nice hot days in the meanwhile. It's gonna be quite hot now, probably not bearable in this office for the next couple of weeks, but anyways, thank you for coming here, thank you for joining me, and I'm gonna see you as soon as possible. So if you're still subscribed and you have the bell notifications on, check out a few of my of the notifications. I'm gonna post maybe some pictures in the meanwhile while I'm working on other things, and then we're gonna meet each other in the next live stream here on the channel. It was fun as every time. So good night and good day wherever you are in the world. Thanks for joining. Bye bye. Gute Nacht.